Okay, so in this lesson, we're going to work problems that incorporate all of the properties we've learned in previous lessons. And so if you recall the properties of exponents that we've talked about, we talked about the product rule, which says that when you multiply like bases, you add exponents. We talked about the quotient rule. When you divide like bases, you subtract exponents. We talked about the power rule. So when you have a power raised to a power, you multiply those exponents. We talked about the power of a product. So when you have a product raised to power, you take each of those factors and you raise it to that exponent. So a to the m, b to the m. We talked about the power of a quotient. So when you have a quotient being raised to an exponent, you take the numerator, raise to the exponent, take the denominator, raise to the exponent. We talked about the zero property, the zero rule, that when you have a non-zero number raised to the zero power, that's going to be 1. And we talked about the negative exponent property. So to make that exponent positive, you're going to take the reciprocal of the base. So b to the negative n, you can write as 1 over b to the n, which means the same thing as 1 divided by b to the n. Okay? All right, so let's look at some examples. So in number 1, let's suppose we had this example in number 1. We had x to the negative 5th power times x to the, let's say, 2nd power. Okay, so the first thing we're going to do there is the best way to do this is to notice I can use the product rule. So when you multiply like bases, you add exponents. So this becomes x to the negative 5 plus 2, negative 5 plus 2, which becomes x to the negative 3rd power. Okay, but I don't want any negative exponents. Okay, so you want the exponents to be positive. So write answers in positive exponents with positive exponents with positive exponents. Okay, all right. So I have a negative exponent, so I got to make it positive. So I know that x to the negative 3rd means 1 over x to the 3rd. Okay, so that's number 1. Number 2. What if you had x to the negative 8th times x to the 10th power? Same thing, right? When you multiply like bases, you add exponents. So that's just x to the negative 8 plus 10 is 2. So it's going to get x squared. And so the power is positive. You're done. That's your answer. Not difficult at all. Number 3, what if you had 4 times x to the negative 5th times x to the 5th? Well, first of all, let's go ahead and use the product rule. So the product rule says when you multiply like bases, you add exponents. Negative 5 plus 5 is 0, correct? So that becomes 4 times x to the 0. But then what's being raised to the 0 power? Well, the only thing being raised to the 0 power is this x. So that's the only thing that's going to be a 1. So I get 4 times 1, which is 4. So the answer is 4. All right, so number 4. Okay, so number 4, what if you had x to the 4th divided by x to the 8th, right? So x to the 4th divided by x to the 8th. So I'm going to use the quotient rule this time. So the quotient rule says when you divide like bases, you subtract exponents. So this becomes x to the 4th subtract 8. But remember, 4 subtract 8 is a negative 4. So I get x to the negative 4, but remember that you want your answers written with positive exponents, so that takes us back to something like number 1. So x to the negative 4th is 1 over x to the 4th. That's number 4. Number 5, what if you had, let's say, a squared times a divided by a to the 5th? A squared times a divided by a to the 5th. Well, same idea. I'm going to use, if you look at the numerator, simplify the numerator first, multiplying like bases, so I add exponents. So a squared times a to the 1st is a to the 3rd divided by a to the 5th. So I use the product rule here. Now I'm going to use a quotient rule. So when I use a quotient rule, when I divide like bases, I subtract exponents. So I get a to the 3rd minus 5, which is a to the negative 2nd. But remember, you want your exponents positive, so you're going to rewrite this as 1 over a squared. So there's your answer. So a to the negative 2nd is 1 over a squared. Number 6, what if in number 6 you had k to the negative 6 h to the negative second power divided by, let's say, k to the third times, let's say, h. All right. Okay, so there are a lot of negatives in there. So don't let that throw you off. So think about what we've done in the past. So what we've done in the past was first of all, the numerator, I can't use any properties in terms of multiplying like bases. None of these are like bases. So the way I would do this is I would group the k's together and group the h's together. That's the way I would do this. So this becomes k to negative 6 divided by k cubed times h to the negative second divided by h. That's the way I would think about that. And then I would use the quotient rule now. So this becomes k to the negative 6 minus 3. So when you divide like bases, you subtract exponents. Negative 6 subtract 3 times h to the negative 2 subtract 1, because that's understood to be a 1, right? Now let's simplify the exponent. So that's k to the negative 6 subtract 3 is a negative 9. And then negative 2 subtract 1 is a negative 3. I don't want any negative exponents. So I know that k to negative 9 also means 1 over k to the 9th power times h to the negative third means 1 over h to the third. And you'll write this as one expression, one fraction. So 1 times 1 is 1. So you get 1 divided by k to the 9th, h to the third. And that's it. That's all you do. So just using those different properties that you've learned about. Okay, so that was number 6. Let's look at number 7. So number 7, let's suppose we had this for number 7. All right, number 7. Okay, so number 7, we have, let's say we had w to the negative 9th times w cubed raised to the negative 5th divided by w to the 4th power. All right, so w to the negative 9th times w cubed raised to the negative 5th times w to the 4th. So there's a lot of stuff there, but look at it in a strategic way. So notice that I have some parentheses here. So let's try and get rid of these parentheses first. See if that can help. So I know that I'm going to use the power rule here. So 3 times negative 5 is a negative 15. So here's what I have so far. I have w to the negative 9th times w to the negative 15th divided by w to the 4th. Okay, and now that's going to take us something similar to, if I can find it, something similar to that one, where I multiplied the like bases here in number 5. So same thing here. Multiply like bases, you add exponents. So that becomes w negative 9 and a negative 15 is a negative 24 divided by w to the 4th. And now I'm going to use the quotient rule. Divide like bases, subtract exponents. So that becomes w to the 24th minus 4. So that's w to the negative 28th. But you don't want any negative exponents. You got to rewrite this. So that'd be 1 over w to the positive 28. And that's the answer. Okay, so that's number 7. Number 8. So it's not a difficult process at all. It's not difficult. It really isn't. So in number 8, let's say I have 4 to the negative 5th power divided by 4. 4 to the negative 5th power divided by 4. Well, 4 to the negative 5th, now that one's easy compared to the others. You're going to do the same thing. You're going to, when you divide like base, subtract exponents. So that's 4 to the negative 5th minus 1, which is 4 to the negative 6, right? And then making that positive exponent, you get 1 divided by 4 to the 6th. You can leave it like this. Or you can actually figure out what 4 to the 6th is on your calculator. So 4 raised to the 6th power gives us 4,096. All right, so that's number 8. Number 9, let's look at number 9. Number 9, we have x to the negative 3rd, y to the 4th, divided by x to the negative 5th, all raised to the 0 power. So that's what I have. Don't make it difficult. Don't make it difficult. Think. You have and assume that the variables are not zero, don't represent zeros. So notice that you have this base here. All of this is a base, and that's being raised to 0 power. Right away, what should you say? Right away, you need to say that's equal to 1 by using a zero rule or the zero property. Any non-zero expression raised to the 0 power is going to be 1. All right, so that's just 1. Okay, let's go number 10, though. So number 10, let's suppose I had 7x to the 4th, y to the 0, all raised to the negative second power. Suppose I had that. All right, now let's go ahead and simplify what we can. Now here's the easiest way to do this. You could first of all think, well, I can simplify this because I know that's 1, right? So that's going to become y to the 0 is 1. So 7 times x to the 4th times 1 is just 7x to the 4th raised to negative second. So make sure you understand that these two are the same thing, because y to the 0 is 1. 7 times x to the 4th times 1, this is 1 right here, is this. Okay? And then I can think about this idea next. I have this base being raised to negative power, so I'm going to make this power positive by taking the reciprocal of that base. So 1 divided by 7x to the 4th, all raised to second power, just like that. And then 1 to the second is 1. And then 7 squared, see that's 7 squared, right? Just rewrite if you have to, and then x to the 4th squared. So this to the second, this to the second, just like this. So that's 1 divided by 7 squared is 49. And then x to the 4th squared, 4 times 2 is 8. So you get 40, in the denominator, you get 49x to the 8th. All right, so it helped if you thought of y to the 0 as 1 right away. Now, if you didn't, you can still approach this, right? If you did not, you can still think of it this way. So watch. So this is number 11. Let's do number 10 with a star. So you can still approach it this way. So you had 7x to the 4th, y to the 0, all raised to negative second. So you can think of it as, well, I'm going to go ahead and make this exponent positive by taking the reciprocal of that base, which you could, just like this. And then all this being raised to the positive second power. And then 1 to the second power is 1. And the denominator, you have this, right? And so you're going to say 7 squared, watch, 7 squared, x to the 4th squared, and then y to the 0 squared, right? Well, so this becomes 1 divided by 7 squared is 49. X to the 4th squared, 4 times 2 is 8, so that's x to the 8 using the power rule. And then 0 times 2 is 0. But you got to simplify it as much as possible. You know that y to the 0 is 1, so this is 1 right here. And so the answer is 1 divided by 49, x to the 8, which is what you had here. Okay, so that's number 10. All right, let's look at number 11. So number 11, let's suppose you had this in number 11. Okay, so you have this expression you want to simplify. Notice, first of all, there are no negative exponents. That's a good thing, right? There are no negative exponents. So that's a good thing. So I just got to use some properties that I know about. So be careful. Don't go directly and say multiply like base you had exponents, because notice that this parentheses is being raised to the 3rd power. So you got to deal with the power of a product. You got to do the power of a product rule first. Okay, so you got to be careful. So dealing with this, I'm going to go ahead and do that here. So 5x squared y to the 4th cubed. So dealing with that, I get 5 cubed, x squared cubed, y to the 4th cubed, right? That's what that means. So 5 cubed is 5 times 5 times 5. Use your calculator. That's 125. X squared cubed, that's 2 times 3 is 6, so x is 6. And then 4 times, the power rule here, 4 times 3 is 12, so it's y to the 12th. So that is going to go here now. So that's this. Okay? So 125, x to the 6, y to the 12th times. Now notice I have parentheses here. I'm going to cover this up. I have parentheses here, but that's being raised to the 1st, isn't it? So xy to the 4th to the 1st is still xy to the 4th. And now I can use the product rule. So x to the 6 times x is x to the 7th. So it becomes 125. X to the 7th, x to the 6 times x. When you multiply like bases, you add exponents. 1 plus 6 is 7. Over here you have the y's, y to the 4th, y to the 12th. So it'll be y to the 16th power. All right, so that is number 11. Okay, not difficult at all, fairly simple. Number 12. Okay, what if we had number 12, we had, let's say, 2y cubed z to the 5th divided by 4, let's make that 5, I'm sorry, 5 y to the 0, all raised to the 3rd power. All right, so no negative exponents, but I do see a y to the 0, so remember, see the y to the 0, make it simple. You know right away that that's 1, right? So I'm going to go ahead and do this. I'm going to say 2y cubed z to the 5th divided by 5, all raised to the 3rd power, because note, y to the 0 equals 1. So that's a 1 there. 5 times 1, so when we had this, 5 times 1 is 5. So that's what you see here. And now I'm taking the power of a quotient, so this becomes 2. So you can take the numerator, raise it to that power, so 2y cubed z to the 5th, all raised to the 3rd power, and the same thing in the denominator. And then in the numerator, you're taking the power of a product, so you can say 2 to the 3rd times y to the 3rd cubed times z to the 5th cubed divided by 5 cubed. Well, 2 to the 3rd is 8, so simplify that. Y to the 3rd raised to the 3rd power, 3 times 3 is 9. 5 times 3 is 15, so that's z to the 15th divided by, and then 5 cubed again is 125. So there's your answer. Okay, that's all you do. It's not difficult at all. It's just using all the different properties that you've learned about. That's all that is. Okay, let's look at 13. So number 13, let's suppose you had, let's say we had y to the negative 5th squared times y to the 6th divided by y to negative 4th raised to negative 3rd. So let's suppose we had that. So again, we're dealing with negatives, so don't let that throw you off. Just simplify as much as possible. Just think about this strategically. So you need to get rid of those parentheses to begin with. So notice in that first parentheses right here, you're raising it to a power. So we're going to use the power rule. Negative 5 times 2 is negative 10. So this becomes y to negative 10th times. Now notice that in this parentheses, that's just y to the 6th to the 1st. So this will be y to the 6th. So this is what I get so far. Okay. In the denominator, I'm going to use the power rule. Negative 4 times a negative 3 is a positive 12, right? So I get y to the 12th. And then notice it got a little bit easier, so I simplified this to look like this. So in the numerator, notice that these are like bases. So when you multiply like bases, you add exponents. So that's y to the negative 4th. Negative 10 plus 6 is a negative 4, divided by y to the 12th. And now I'm going to use the quotient rule. So using the quotient rule, when you divide like bases, you subtract exponents. So it becomes y to the negative 4th minus 12. So negative 4 to negative 12 is a negative 16. So I got y to negative 16. But I don't want any negative exponents. I want all my exponents to be positive. So by definition, that's going to be 1 divided by y to the 16th. And so that's the answer. Okay. So be strategic as you go through this simplification. Don't make it difficult at all. Okay. All right. And then number 14, so let's suppose we had this number 14. We have a to the 5th, b to the negative 3rd, divided by c to the negative 5th. So that may look a little more difficult than some of the others, but it shouldn't be. Let's think about this strategically, okay? The way I would do this, as I think about this, is this way. So I would look at what I have here. So I have a to the 5th and b to the negative 3rd in the numerator, and I have c to the negative 5th. I want you to think about it this way. So a to the fifth, I can write as a to the fifth divided by 1 times. You see this fraction here, I can write it like what I'm doing. The c to negative 5 is in the denominator, so I can write this as 1 divided by c to negative 5. And then b to negative third, I can write as b to negative third divided by 1. This product, I want you to recognize is this. A to the fifth, c to negative 5 is in the denominator, b to negative third is in the numerator. And then let's try and make this positive. The exponent's positive. So this exponent's already positive, right? So that's going to stay as it is. So this fraction is going to stay like this. For this one, 1 divided by c to negative 5 is just c to negative 5 divided by 1. I'm sorry, c to positive 5, excuse me, positive 5, because you bring it to the numerator. And then this is negative in the numerator, you're going to bring it to the denominator, so I'll be, times. So I'll be 1 divided by b to the third. And so then the answer becomes a to the fifth, c to the fifth times 1, which is a to the fifth, c to the fifth. And the denominator, 1 times b cubed, is b cubed. Okay? Now, the way that students think about it, though, is this. If it's negative in the numerator, where do you bring it? To the denominator. If it's negative in the denominator, where do you bring it? To the numerator. So this exponent is positive, so it stayed in the denominator. It stayed in the numerator. That's why you see it. B cubed, to make that exponent positive, you bring it to the denominator. C to negative fifth, to make that exponent positive, you bring it to the numerator. Okay, so real quickly, what would you do if you had this? 4 x to the negative fifth, y to the third, divided by a to the negative seventh, b to the fifth. All right. So notice that there are no like bases here, so you can't use those properties, but you do have negative exponents, and you want to try and make those negative exponents positive. So you want the answer to have those negative exponents, positive exponents. So if you notice that this expression here has a negative exponent, and this expression here has a negative exponent. All the others do not, so they stay where they are. So in terms of your answer, you're going to say I need to bring this x to the negative fifth in the denominator to make that exponent positive. And then here, where I have this circle in the denominator, I got to bring it to the numerator to make that exponent positive. So I get 4 a to the seventh, y to the third, because that exponent's already positive, divided by, and then x to the fifth times b to the fifth. Okay? So now all I did was I took what was circled and I brought them in their respective areas in the expression. All right, so that's 15. Okay? All right, let's look at 16. So in 16, let's suppose we had this. So 16. All right, let's suppose we had, in parentheses, we have in the numerator, negative 2, x to the negative fifth, y to the fourth, that's a 4, divided by 3, x to the sixth, y to the negative second, all raised to the negative third power. Okay, don't let that be an issue for you. Don't let that be an issue. It's not that difficult. You can deal with this. What I would do first of all is this outer exponent right here is negative. So what I would do is I would make this exponent positive to begin with. That's what I would do, this outer exponent. So to make that outer exponent positive, we're going to take the reciprocal of this base. Okay? So when I take the reciprocal of the base, I get this. I get the denominator becomes the numerator becomes the denominator. So I get 3 x to the sixth, y to the negative second, divided by negative 2, x to the negative fifth, y to the fourth. Now this is being raised to the third. Okay? I still have negative exponents, but at least I have one less. So to bring that outer exponent positive, I took the reciprocal of this base. Okay. Now, what we got to do next is we're taking the power of a quotient. So then, now this is a pretty long one because it involves quite a few of those properties. So then I'm going to take the numerator, raise to that power. So 3x to the 6th, y to negative 2nd, raised to the 3rd. And the denominator as well. Negative 2x negative 5th, y to the 4th, raised to the 3rd, just like this. And then I'm going to take the power of a product now. So then this becomes 3 cubed times x to the 6th cubed, just like this, times y to negative 2nd cubed, right? All divided by, and then the denominator as well, negative 2 cubed, in parentheses, just like this, x to the negative 5th cubed. So each, you're taking a power of a product, the power of a product. So each of these has to be raised to the 3rd power, times y to the 4th cubed. And then let's simplify each one. 3 cubed is 3 times 3 times 3, which is 27. X to the 6th cubed, 6 times 3 is 18. Y to the negative 2nd cubed, negative 2 times 3 is negative 6. Divided by negative 2 to the 3rd power is a negative 8. Negative 5 times 3 is a negative 15. And then 4 times 3 is 12. So I get y to the 12th. So that's where I'm at. Okay? Now, I still have negative exponents, but I also see that I am dividing like bases here. So what I would do is I would write like this first. I would say, well, that's going to be negative 27 divided by 8 times x to the 18th divided by x to the negative 15th times y to negative 6 divided by y to the 12th. And then let's simplify each of those fractions. So negative 27 over 8 I cannot reduce. I'm going to leave it as a fraction. Here I'm dividing like bases, so I'm going to use the quotient rule. I'm going to subtract exponents. So it'll be x to the 18, subtract a negative 15, times, and the same thing here, divide like bases, subtract exponents. So it'll be y to negative 6, subtract 12. So simplifying this further, so it's quite a few steps, isn't it? So, and notice along the way you can easily mess up, so be very careful as you go along. So negative 27 divided by 8 times 18, subtract a negative 15 means 18 plus 15. And then when you add those two, 18 plus 15, you get x to the 33rd power. And then y, a negative 6 and a negative 12 is a negative 18. So that's where we're at. I have a negative exponent still right here, right? So I need to bring that to the denominator. So I get, in my numerator, I'm going to get negative 27 x to the 33rd power times 8 y to the 18th. And so that's the answer. Okay? So that's going to go in the denominator. And that's it. So that's a quite a few problems that we did utilizing all these properties that we learned about in the previous lessons. All right, so just know that there are many problems where you are going to have to use multiple properties, not just one, not just two, not just three, but you're going to have to use several of these properties in that particular problem. Okay, so that is the end of this lesson.